I, Dr. Kaveri Das, welcome you to the third session of Data Mining Introduction. Here in this session, we will discuss the data mining functionalities. So, the data mining functionalities is nothing but the kinds of data patterns generated by the data mining system. So, it is very important for the user that what are the different type of patterns they are going to generate from different kinds of data set, and which will help them to meet their expectations in a research area. So, this particular session is covers our course outcome 1, that is to understand the importance of data mining and its application in various areas, which covers our program outcomes, that is program outcome 1, apply the knowledge of engineering specialization, and program outcome 2, that is identify and analyze complex engineering problems. The content for this session includes data mining functionalities, that is concept, class description, characterization and discrimination, mining frequent patterns, association and correlation, classification and prediction, cluster analysis, outlier analysis, evolution analysis, and followed by summary. Now, data mining functionalities. Data mining functionalities are used to specify the kinds of patterns to be found in data mining tasks. So, here we are going to find out the different kinds of pattern we are finding by applying our different techniques of data mining. Data mining tasks can be classified into two categories, descriptive and predictive. So, before that we will discuss about why we are going for this study of functionalities, the data mining functionalities. Here users may not have the idea about the kinds of pattern in their data. It may be interesting. So, which type of data patterns, whatever the data patterns we are getting, whether they are interesting, and they are not having the idea that they may search in several kinds of pattern in parallel. So, while applying we may got several kinds of patterns. So, hence it is important to have a data mining system that can be mined multiple kinds of patterns to accommodate different users' expectation or application. So, we have a multiple data pattern type which can meet our expectation, and the data type also differ from one technique to another technique. So, here we are going to discuss about two types of category of data mining classification, that is descriptive mining and predictive mining. Task which categorize the general properties of the data in database is a descriptive data mining. So, where only we are having a general features, so general characteristics of database we are discussing, that is a descriptive data mining. And predictive mining, it task perform inference on current data in order to make prediction. So, here we are going to predict the future data on the basis of the characteristics and the occurrence of a current data or the analysis of the current data. Now, data mining functionalities. It includes concept class description, where we will discuss about characterization and discrimination, mining frequent pattern, association and correlation, classification and prediction, cluster analysis, outlier analysis, and evolution analysis. So, first we will start with the concept class description, where we will discuss about data characterization. Data characterization is a summarization of a general characteristics or features of a target class data. So, here in our database we are having a target class, that means a class level attribute, where we are going to summarize or studying the characteristics or the features of that target class. Here the data corresponding to the user specified class are typically collected by the database query. So, here whatever the task you want or whatever the information we require, we can collect it by triggering a query to the database. Example, to study the characteristics of a software product whose sales increased by 10% of the last year, the data related to such products can be collected by executing an SQL query. Now, suppose we want to find out a particular product whose sales value increases by 10%. So, this type of thing can be retrieved from the database by putting a query, SQL query in the database, and we can retrieve the data about the particular sales data where the particular software product whose sales value has been increased 10% in the last year. So here we are specifying a typical characteristics of a data, that's why it is coming under the characterization data category of data characterization. Now data discrimination. So for this data characterization, we are using several type of methods, like method for data summarization based in statistical measures. So those things we will discuss in chapter 2. We can use OLAP, that is OLAP on online analytical processing roll up operation technique, where we can use a data cube aggregation technique which can view the users it can be used to perform users control data summarization method. Same method can be also used for data discrimination. Data discrimination is a comparison of the general features of the target class data objects with the general features of the objects from one or set of contrasting classes. So here we are going to compare between two class level attributes, or here we are having a target class. The features of the target class can be compared with the general features of objects from other contrasting class. For example, suppose we are discussing about the software product sell value increases by 10%. We are comparing the same product with a particular product which sales value decreases by 30% last year. So where we are having a contrasting characteristic, like one value increases, one sell value increases and another product sell value decreases. The target and contrasting classes can be specified by the user and the corresponding data objects retrieved to the database query. So here also we can have the comparison result, or we can get this type of result from the database by using a database query. Now the next functionality, that is mining frequent patterns, association and correlation. So here first we will discuss about what is a frequent pattern. It is nothing but patterns that occurs frequently in data. So there are various kinds of frequent pattern we are having. One is frequent item set, another is frequent sequential pattern, another is frequent structured pattern. So what is frequent item set? It refers to a set of items that frequently appear together in a transactional data set such as milk and bread. Now suppose in a transactional data set, generally we are having transaction ID which reflects the identification number of a particular transaction and which stores the number of items for that transaction. So if we will have a similar type of item occurs in almost all transaction or most of the transaction, then we can say that that is a frequent item set. For example, milk and bread. Suppose most of the customer has taken milk and bread and it is easily seen in our transactional data set, then we can say it is a frequent item set. Next is frequent sequential pattern. A frequently occurring subsequences such as the pattern that customers tend to purchase first PC followed by digital camera and then a memory card. Now suppose we are going to a market and we are first purchasing PC, then we are asking for digital camera and then for a memory card. If most of the customers are doing following this particular frequency or subsequence, then we can say this particular subsequence is a sequential pattern. So it is coming under the category of frequent sequential pattern. Next is frequent structured pattern. A substructure can refer to different structural forms such as graphs, trees, lattice, which may be combined with item sets or subsequences which occurs frequently. Now suppose we are having a item sets like graphs, trees, lattice. If that can be combined with a transactional data set or the items, then if it is occurring frequently, then we can say it is under category of frequent structured pattern. Now here we will discuss about association analysis, where first we will discuss about multidimensional versus single dimensional association. So before that, first we will discuss single dimensional association rule. So let me first describe what is a association rule. Association rule that contain a single predicate is known as single dimensional association rule. Now this is an example of an association rule which is a single dimensional association rule. It is written by X computer buys X software. This is then support 1% and confidence 50%. So here first of all we will discuss this side, buys. This is nothing but a predicate. So here we have used a single predicate, buys and buys in both the sides of the rule. So here this X stands for a customer. It is a variable which represents the customer. The meaning of this one is, buy, a customer purchasing computer also purchase software. Software support 1%. The meaning of support 1% means 1% support means that 1% of all the transaction under analysis showed that the computer and software were purchased together. That means suppose we have a number of transactions, out of that it has been observed that 1% in 1% of the transaction where the customer has purchased both the computer as well as software. And what is confidence 50%? Confidence for 50% means the customer has buys a computer and there is a 50% chance that he or she will buy a software as well. So this is the meaning of software and confidence. So this rule can be a association rule, and remember always the association rule can be supported with support and confidence. These are the very two important term, and this will be later will explain in detail in chapter 5, frequent pattern and association correlation analysis, that we will discuss later. Now why we have called this particular example as a single dimensional, as we are using a single predicate over here. Now we go to the association rule. So multidimensional association rule is nothing but association rule that contain multiple predicate. We can see this example, age x 20 to 29, income x 20k to 29k, buy x CD player, where support is 2% and confidence is 60%. So here x is a customer, age is a predicate, income is a predicate and buys is a predicate. You can able to see that we are using multiple number of predicates here. That is why this example coming under your multidimensional association rule. The example says a customer within the age group 20 to 29 and their income level should be 20,000 to 29,000. That means they buy the CD player. Support 2%, that means whatever the transaction we are having under analysis, 2% of the transaction shows that age group of this 20 to 29 and income level of 20k to 29k customer has already purchased CD player. And confidence 60% means we are having this age group and income group customers and there is a chance they may purchase the CD player. Now classification and prediction. Classification. It is a process of finding model or function that describe and distinguishes data classes or concepts for the purpose of being able to use the model to predicate the class of objects whose class label is unknown. So first of all I should tell you, classification is a supervised model. Why? Because whenever we are creating a classifier or making a classification, it is a two-step process. The step one is making a classifier, second one is use of the model. So how we are going to find a model or construct the classifier? We are having a training data set, transactional data set, where 70% of the data tuple can be represented as a training tuple, which can be used to make the classifier. So we are studying or analyzing those 70% of the training tuple to learn or generate the rules from that one, which can be used to construct the model. So once the model has been constructed, it can be applied for the to check whether the model is correctly working or not to the rest 30% of the data tuple in the database. So that is known as testing tuple. So if the model is working perfectly, then we can able to apply it on the unseen data. That means where we do not know the class label, that is the unknown class label. So the role of the classification is, suppose we are making a group, then a new tuple comes where we do not know the class label, we can able to classify that particular tuple belongs to which group with the means of a classifier or our model. That's why this is known as a supervised method. The derived model is based on the analysis of a set of training data. Is already have explained about this. Data object whose class label is known. So, training data means that will help you to train our classifier. That is why we know the class label of the training data. Based upon that, we learn our classifier, and our classifier will be ready to classify the on-scene data. Now, question is, how is the derived model presented? Represented by classification models such as if-then rules, decision tree, mathematical formula and neural network. So, these are different classifier where we can able to classify our data. If-then rules can be used to classify if then we are having with the rule if satisfy, then part satisfy, then we can have a generate a rule. It can be also constructed from the decision tree. Then decision tree. Decision tree is nothing but a flowchart like structure where each node denote a test on an attribute value and each branch represent an outcome of the test, and then the leaf represent the class label. So, decision tree can also used to generate the classification rule. So, where we are testing on each root node, then the branch generated, then we can have a test on branch node, then the next branch will be generated, like that. At the leaf label, we are having a class label attribute. Leaf node represent the class label attribute. So, like that we are having mathematical formula and neural network. Neural network is a collection of neurons like processing unit with weighted connection between the units. So, where we are having a different layer like input layer, hidden layer, output layer. Every layer is having some nodes where the input layer is having the inputs and which is weighted. There is a weighted connection between input to hidden layer and hidden to output layer. Detail we will discuss in chapter 6 about neural network which will be helpful to classify our data. Apart from that, we are having some other classifier model like SVM, then K nearest neighbor classifier, Bayesian classification, rough set approach, genetic algorithm. So, there are several classifiers they are having, which detail we will discuss in chapter 6. This is the figure of whatever I have discussed about the if-then rules, decision tree and neural network. You can able to see here in this figure A, it represents the decision if-then rules, that is age X youth and income X high, class X A. So, here these particular rules, this is the if-then rules which can be derived from the decision tree. So, first let me discuss about decision tree, then I can explain this particular if-then rules generated from decision tree. So, here the figure B shows the decision tree where already I have told you we are having a at root node we are going to test on an attribute. So, the attribute name is age. So, we have put the question mark on age. Age is having the value, suppose youth, middle age and senior. So, if it is youth, then this branch will be developed, and if it is middle age and senior, then this side branch will be developed. Then again at this particular node we are having a test on another attribute, that is income. Income can be high and income can be low. So, here you can able to see that this particular symbol represent the leaf node, this already you know. So, here if age is equal to youth and income is equal to high, class label is equal to A. If age is equal to youth, income is equal to low, class label is B. So, you can able to see this first two lines of the figure A, which represent if-then rules which is generated from this decision tree. You can see here age, if age is equal to X means it is a customer age is youth and income high, then class of that customer is A. Then customer is youth and income is low, then class is B. Then another if you see the other side, if age is equal to middle age, then the class label of that customer is C. If age is equal to senior, then class label is equal to C. So, now we can able to see that how we can able to find out, we can put the questions on the root node, according to that we can develop the branch node, then we can like that we can continue, and the class label attributes can be reflected or it can be represented by the leaf node. So, these are the rules which can be if-then rules which can be derived from the decision tree. Now come to the figure C, where the same concept has been explained with a neuron-like structure, neural network. So here you can able to see that in the input layer we are having two node F1 and F2, which gives the input about age and income. Then at the hidden layer we are having three node, all the connections are weighted connection. Then at the output layer we are having three node, one node represent class A, class B, class C. How it works, that we will discuss later. So this particular figure represent is a classification model, can be represented in various forms such as if-then rules, decision tree or neural network. So this figure has been taken from the book Data Mining Concept and Techniques by Han and Campbell. And now prediction. Prediction is whereas classification predicts the categorical or discrete unordered labels, prediction models the continuous valued functions. So prediction always used for the continuous valued functions. It will not give you the particular class level, rather it will give you, it is used to predict the missing value, the unavailable numerical data in the database, or for the rather than the class label. So we have to see that where we can able to use the prediction terms. Like we can say, if your research work is a stock market exchange value, then there we can use the term prediction or the technique prediction, not the classification. If it is a weather forecasting or gold value prediction or dollar value prediction, so these things can be done by your prediction technique. Regression analysis is a statistical methodology that is mostly often used for numeric prediction. So this is a method by which we can able to apply the prediction. There are several methods like log linear model, linear regression analysis, multiple regression analysis. Those things we will discuss later. So these are the various techniques can be used for prediction. Next, clustering. Clustering analyze data objects without consulting known class label. So as already have discussed about classification, there also we are grouping a similar type of objects. In clustering also we are grouping a similar type of object, but the difference is classification is a supervised method and clustering is a unsupervised method. So why clustering is an unsupervised method? Because in clustering we are not making any model or classify to classify the data label. So here it can be analyze the data objects without consulting known class label. We do not know the class label, but we can apply the clustering. The objects are clustered or grouped based on the principle of maximizing the intra-class similarity and minimizing the inter-class similarity. So these two terms are very important. So whenever we are making a cluster, that means groups, we have to think that we have to say how we can able to say that this cluster is a glued cluster. So if the intra-class similarity is high, that means within a class the similarity between the object is high, that means that they are of similar type of objects. So your group is very good. And minimize the inter-class similarity, that means an object of one cluster should minimum different minimize the inter-class similarity, the similarity of the object of one class with object of other class, that should be minimum. So similarity, if that is minimum within other class and maximum within same class, then we can say the cluster is a good cluster. Each cluster that is formed can be viewed as a class of objects from which the rules can be derived. And now outlier analysis. The data objects that do not comply with the general behavior of the model of the data, it can be known as outlier. So outlier means where suppose we are having a data set where all the objects are similar type and some objects are there which doesn't match with the behavior of the object, then we can say that is the outlier for the data. So the analysis of outlier data is referred to as outlier mining. Now for example, suppose I have a data class of flower. So all the type of flowers are there, their characteristics are very similar and behaviors are similar. So in that particular class one animal will be there added, then we can say the features of the animal will differ from the features of the flower. So that can be taken as an outlier. Outlier may be detected by using statistical test and using distance measure. So statistical test is assumes a distribution of probability model for the data. So how to check the outlier? For that we can use the probability method if you are using a statistical test. And in distance measure, where objects put that a substantial distance from any other cluster are considered as outlier. So here if the objects is having much more distance from any other cluster centroid, then we can say that is not belonging to the particular group, and that's why that is a separate object which should not be added with the group. So by distance measure also we can able to detect the outlier. And the next functionality is evolution analysis. What is data evolution analysis? It describes and models regularities or trends for objects whose behavior changes over time. Now whenever we are studying any technique, whenever we are applying, we cannot say that always it will be giving a same result. So whose behavior changes over time, then that is coming under your evolution analysis. It may include the techniques like characterization, discrimination, association, correlation analysis, classification, prediction or clustering of time related data. Distinct features such as analysis include time series data analysis, sequence or periodicity pattern matching, and similarity based data analysis. So these are one techniques. So some of the techniques already we have discussed in our earlier slides. So here we cannot say that all these things will give you a similar type of result every time. So time to time, according to the user's requirement, it may gives a different result or different patterns. So that's why we are saying that is the trend is known as evolution analysis. And now summary. Data mining functionalities include the discovery of concept class description, association and correlation, classification, prediction, clustering, trend analysis, outlier and evolution analysis, and similarity analysis. So these are the different type of functionality which we have already discussed in this session. This is very much important for our research point of view, as it depends upon the user is interested in which area. We have only briefly categorized or discussed about this technique, but not in detail. So these things will be detailedly studied in coming chapter. Like in chapter 2 we will discuss about data pre-processing techniques, then chapter 5 association and correlation analysis, then chapter 6 classification and prediction, in chapter 7 clustering analysis. So here the user has to find out which particular technique the user wants for their data set. So the user should know what are the data types upon which the user will apply the techniques that already we have discussed in our previous session 2, and here the users has known about, have the overall idea about the different technique of data mining which can be applied on the data. So now it depends upon your research domain in which you are going to work, and according to that you have to pick the particular topic or particular technique and your data set to apply on that. So characterization and discrimination are forms of data summarization which can be discussed in our later chapters. These are the basic things what we have discussed till now. With this I conclude this session. Thank you.